Very good. All right, we're just going to talk today about bore welding and shot sleeves. If anyone has any questions during the presentation, yeah, you can call in at any time. All the sleeves, when they come in the cast tool and get ready for bore welding, we have to wash them. We do a dry ice pressure wash, and this will remove all the aluminum paint, grease, oils from the sleeve that could contaminate the sleeve during the process. Once the sleeve's clean, we look the sleeve over for any types of cracks and heat checking in the sleeve. You'll note on this sleeve, we bored out some of the heat checking to check the sleeve for hardness. In the area of the heat check where the sleeve is exposed to higher temperatures to draw the sleeve, it's 32 Rockwell. This is not a good candidate for bore welding, A, because of the heat checking, and B, the 32 Rockwell will not support the weld in the application in use. If you look at this sleeve here, it has severe washout. We went ahead and cleaned under the pouring spout of this sleeve, and you'll see in the next slide. It didn't clean up in the prep, and also it revealed a crack. Again, this is not a good candidate to bore weld because the crack will propagate. So when the sleeves come into cast tool, after the cleaning and what have you, we check the hardness. We also check that the sleeve is a good candidate with any cracking going on. We also clean, oh, give me 1 second. If there is cracking on the sleeve, when we preheat for welding, the crack will run. At this point, we've deemed that we can bore weld the sleeve. We'll send it over to the engine lathe. The sleeve is set up in a 4-jaw chuck and a steady rest, so the sleeve is running concentric to the bore. We remove approximately 3 millimeter or 1/8 of an inch. This will keep the weld uniform. The sleeve at this point goes into the oven and gets preheated. We like to preheat them to about 450 F or 230 C. Once it reaches temperature, we move it very quickly over to the bore weld because we want to retain this temperature throughout the weld. Once we start welding the sleeve, we do a continuous weld. We don't like to stop and start the weld. We like to keep the weld at a uniform temperature throughout. On some sleeves, this could be welding upwards of 4 to 6 hours of continuous arc. After welding, we put the sleeve back in the oven and do a stress temper on the sleeve. Once the sleeve is done stress temper, we let it cool and take it back to the engine lathe for boring and getting it ready for honing. On some sleeves where the pouring spout is too large, 130 millimeter or 5 inches, we have to put a bridge in the pouring spout area. This will prevent the honing stones, from trying to come out of the pouring spout during the hone, and it also keeps the bore concentric to the OD. We have special stones made up for our hone to extend the length of the stone to cover the pouring spout area with the bridge. The sleeve is now ready for nitride and final inspection. We check the bores before and after nitride. I'd like to stop here and talk a bit about heat treat and nitride. Um, because the nitride temperature encroaches the last draw temperature of the heat treat, it's important that we know the last draw temperature in heat treat. When we are bore welding our own sleeves, we know these temperatures. If we are bore welding a sleeve that we didn't manufacture, this could become a concern, because if we nitride to a higher temperature than the last draw, we could put a draw on the sleeve, which may distort the sleeve. This is when we talk about bore welding sleeves, we'd like to know who heat treated it and the last draw temperature. If the sleeve has too much washout in it, but is still a good candidate to bore weld, we do have some options. We could put an insert in the badly washed out or heat checked area. As you see in the pictures above there, it's just a sample of what we can do with some of the inserts in sleeves. That completes everything with bore welding. Any questions? You can come forward to Cast Tool and we'll look after you.